Okay, girls, so today we're going to look at electromagnetism and the first right-hand rule. So the field is circular about the wire. The lines are concentric circles with the wire in the center. So if we imagine that this dot was the wire, say coming out of the board, concentric circles means like a bullseye. Alright? A lot of students, when they think of this, they think spiraling out, and that's not correct. So don't do that. The direction of the magnetic field is given by the first right-hand rule. So the first right-hand rule, this is for finding the direction of the magnetic field around a current-carrying wire. So remember that fields have direction. For a magnetic field, it's always what way will a north pole of a compass react. So here's how the first right-hand rule works. Wrap your hand around the wire so that your thumb points in the direction of conventional current flow. Your fingers are pointing in the direction of the magnetic field. So, hold on. If this is our current-carrying wire, now if you remember back to grade 9 science, current can only flow in one direction, right? We can reverse the current by changing the polarity. We can switch the battery around, and then the current will flow in the other direction, but it can only flow in one direction at a time, okay? So if the current's flowing in, I don't know, this direction, in this wire, then you would take your right hand, not your left hand, you would point your thumb in the direction of the current flow, and then you would grab onto the wire, and that will give you information about how the field lines wrap around. So above this wire, there we go, above this wire right here, you can see the current's going towards the camera. So above the wire, I grab onto it with my thumb pointing towards the camera as well. So above the wire, the field lines would be pointing in that direction. As I wrap around, on this side, they would be pointing down. Underneath, they'd be pointing that way. And then this is where it starts to get tricky. And then when you come all the way around, on this side, it would be pointing up. So let's take a look at another way to visualize this. So I'll go back to that screen if you didn't get the notes in just one second. So another way to visualize this, the dot is a cross-section of wire. So I have some wire here. This is actual wire. We can run a current through it. So if the dot represents wire, so you can envision the wires coming right out of the screen towards you, then these circles here represent the field lines that are generated around this current-carrying wire. Now, we only have two options for the direction of the current flow. The current can either flow out of the screen, or it could flow into the screen. So which one do you want to start with, out or in?
Out.
Out. Out it is. So, current's flowing out of the screen, so I point my thumb at the class, right? Because that's the direction the current's flowing. I grab onto the wire, so you can see above, which way are the field lines going to point? To the left. So as we wrap around, again, my thumb's pointing at the class the entire time. So on this side, we're pointing down. On this side, underneath, we're pointing to the right.
Isn't that always just the same direction?
Yeah.
That's the
The thumb tells us the direction of the current flow. So right now the current's flowing out of the page towards you girls. Okay? Watch what happens if the current's flowing the opposite way. I'm going to do the current going, let's see, blue is current out, and red doesn't show up nice. Green will be current in. Okay. So this is for blue. If we look at green, so we look at current going into the page. So my thumb points at the screen. Again, I'm using my right hand. I'm going into the screen. So when I'm above, which way am I pointing?
Right.
To the right. So you can see how that reverses the field. When I'm on the right-hand side, I'm pointing down. When I'm beneath the wire, I'm pointing to the left. And when I'm on this side, and this is why this is my favorite unit to teach, when you girls write the test, you're all twisting your arms around. Don't injure yourselves. We're pointing up over here. So for this example question, current is flowing towards the class, out of the page, would be another way to put that in a question. Which way would the compass point when placed at? Starting with X. Well, again, first figure out how the field lines are going. So take your thumb, which way is the current flowing? This way, out or in? Out. So which way are the field lines going? Well, they're wrapping around counterclockwise, as Julia likes to say it, but I'll say pointing in that direction. It should be on. So at point X, it would point up, would be one way you could say it, or top of page, or you could say, or you could draw an arrow. It would point that way. For Y, well, you just go all the way around. Y is pointing to the right, or right-hand side of page, or if you want to draw an arrow, you do that. For Z, that's above, so that's pointing to the left, or that way. Now with Q, it's kind of hard to say to the bottom left-hand corner of the page. I would just draw an arrow if you ever get an irregular one like that. Usually I'm going to give you something like this, but I might throw a little curveball at you. Q is like that. Okay? Any questions with that? So moving on to this one. Now this one, usually, you won't get a diagram with it. So the question will appear just as it did on the board here. A wire is traveling with current flowing from north to south. If you placed a compass directly blank, which way would it point? So it's up to you to visualize it. Now what I've done is I've drawn a wire with a magnetic field around it. And what I've done is I said south is going towards us because that's the direction the current's flowing. So south is moving towards us. North is away from us. So north, east is to the right. And west would be to the left. Again, if you were to kind of visualize this from above, here's your wire, current carrying wire with current flowing that way. So it's going from north to south. Over here is east. And over here is west. Okay? So there's two ways to visualize this, depending on what your preference is. If you want to think of it as a bird's eye view, then you need to go with that one. If you want to look at it with the wire coming straight at you, then you need to go with this one. You might want to do both, because now we're talking about 3 dimensions. We're not talking about just the possibility of north, south, east, west, or left, right, forwards, backwards. We also have to consider the 3rd dimension. So, real easy, you can say, okay, well, currents, it's just like the last example where the current's flowing this way. So it's going around like that. If you were to look at it from here, well, the current's flowing this way, so I would wrap around the wire this way. So it's going to, the field lines are going to come around like that and point in that direction. A little bit harder to visualize the field lines from the bird's eye view, but like I said, it might help. So if I place the compass directly above the wire, I'm going to use this one here. So if I place the compass directly above the wire, right here, which way is it going to point?
West.
It's going to point west. With this one, you won't be able to draw arrows. You'd have to actually, unless you drew a really, really good diagram, this would be probably acceptable as long as you've labeled east and west. You could draw the arrow pointing that way. But usually what I'm looking for here is an actual direction, west. In multiple choice questions, it'll just have west, south, north, up, down. So you have to use those ones. When you are directly east of the wire, so here's the wire coming at you, directly east of the wire means you're just right here. So when we're looking at it head on like this, we're just to the right of the wire. So which way is the compass going to point? No, not north. North is that way. It's going to point up. Okay.
So west side is right and left, but north and south are not the same.
No, again, you can't put the labels like that. Okay? If I were to reverse this diagram, Julia, if I were to reverse the current flow and say, okay, now we're flowing north to south, and I reverse the diagram, then east and west would be flipped. So you can't put a standardized rule like that and say, oh, west is always going to be to the left and east is always going to be to the right. It all depends on your setup, just like everything else with physics. It's all in your setup. Okay? So when we're directly east over here, we'd be pointing up. When we're below the wire over here, we'd be pointing east. If I placed a compass directly to the west of the wire, it would be pointing down. So lots of different possibilities. Do you want to do another one of these just to see? I can try and make it a little different.
Okay, west is into the page.
Yep.
You point your thumb that way. So north is on the right side.
Okay.
So the current is going into the page.
Into the page?
Yeah.
Let's see. When we place a compass directly north, it points down. So the field lines are like this.
Isn't the current, the way the current flows, isn't that where your thumb points?
Yes. But this is one that we're doing in reverse. So first we're given the field lines. So we have to figure out which way our fingers are pointing. Our fingers are pointing this way, not this way, right?
Yeah.
So if our fingers are pointing down, then where's my thumb pointing?
So the answer would be down.
No, Aaron, that's what we're given. When a compass is placed directly north of the wire, it points down. So I'm placing my compass right here, and it points down. And that's where I was able to figure out what these field lines are doing. So the field lines are wrapping around clockwise. So they're wrapping around, if you look at my hand, again, this is the wire right here. I'm wrapping my hand around the wire. My fingers tell me the field lines. They both start with F. My thumb is direction of the current flow. So
Oh, west.
it's going that way. So that would be west.
Is this like a question too?
No, that's what the question's asking you to find out, Aaron. What direction is the current flowing in the wire? Okay?
Okay.
So this is an example of a question. Rather than be given the direction your thumb points and figuring out the field lines, this one tells you the field lines in a roundabout way, and then you tell which way your thumb should point. I can't have my compass point up here because I'm told it points down. So if I try to put my hand this way, it's not going to work. So there's only one possible way my thumb can point. And again, it's all in the setup, right? If you set up your diagram, or if you set it up in your mind properly, and you've got everything going the direction it should be going, then it's pretty straightforward and easy.
Yeah.
But it's all in your ability to visualize the setup. Now, if you look at the second question here, the second question is actually easier. Which way is the current flowing in the wire pictured below? So this one, I give you the information. I tell you that it's pointing down here, and then you just have to look at where your thumb points. So it's the same thing. This one's also into the page. And that's how you would say it, into the page. This one, it was into the page, which is west.